So, I've got my Aquila X1 here, and it's pretty much stock. I do have an Easy ABL mounted to it, but it is not connected right now. I just pushed a firmware update, so version 2.4.5 will have official support for the X1, and that's already live on the site. So if you have one sitting around, mine was literally collecting dust. You can dust it off and go ahead and install some firmware. Now, just like the Ender 3 V2 and the Ender 3 S1 color LCDs, these are the same type. There are weird display artifacts. I don't know if I call them artifacts, but basically the display is not perfect. And what I mean by that is if you go into this expecting it to be, perfectly smooth and not have any weird issues, you're going to be sorely disappointed because that's not the case with this particular machine. Now, I'm going to go ahead and switch over to my monitor here, and I'm going to go and open up our website and hit uf2.th3dstudio.com, which takes you right to our help center. So if you're on our main website, you can also get here by going to help center and downloads. Now I'm going to go ahead and hit Voxelab, and this is the Aquila. Now this machine was sold originally under the Aquila. I've also seen it sold as the X1 since the X2 is also out, and this is for the V101 board. And if you notice here, I've got notes saying that you need to make sure that you have the correct CPU type for this firmware, because there's actually 6 total that are supported. There are 2 other variants called the H32 CPUs, which I actually haven't been able to find an actual picture of those processors, just people mentioning them. And apparently it's one that nobody really knows much about, and there's like some weird third-party firmware a guy's been working on that's very buggy. So basically, if you have the H32 CPU stamped on the processor, you're probably not going to be able to do many upgrades on this machine that require firmware updates because the support doesn't exist. This is part of the whole issues where all these companies are swapping out processors at random because of supply chain issues, or just cost. And, the consumers get to deal with the fallout from that. So I just want to make sure to mention this, that you have to select the correct CPU. By default, the firmware is set up to use an STM32 build, but we also have ones for the GD32, the N32, and then 256K and 512K variants. And I'm going to show you really quick how to figure out what processor you have in your printer. So if we look here, I've got my printer on my bench. You take the screw out that's right here. I've already removed my bottom cover. And you flip it up, and there will be 2 other screws at the top here that you have to take off, and then 1 more here, and then the bottom panel removed. So this bottom panel normally sits here, and it does have a cooling fan, so you want to make sure that you unplug the cooling fan from the header here. And now we can look at the processor. And you want to make sure that you have one of these supported processors before you try to install the firmware. So if we look at mine here, if my camera would focus, that'd be great. Come on, we're not a Logitech. We know how to focus. Come on, Sony. Go figure. If I edited this, I would be able to cut this out. But go figure. We are trying to do this live, so I don't have to edit the video. And it's not cooperating. My God. Okay. So you can see there on my processor, it says GD32F103RCT6. So if you have one of these other processors, like the N32, or there's also GD32F103RET6, you got to make sure you set the correct values in the firmware. And it's not hard. I've pre-set up as much as I can. But this is a little more involved in terms of firmware setup than other printers because of Voxelab's decision to just use whatever processor they felt like putting on there at the time based on what they could get for the best price. So let's head back to our website. I'm going to go ahead and download Unified 2 for the Voxelab Aquila X1, and this is going to give me a zip file, okay? So inside this zip file are a couple of different files. One is going to be the actual firmware itself. The other is going to be the LCD firmware. Sorry about that. So I'm going to go ahead and extract these files here, and I'm going to put them in a folder. Now, you can put them wherever you want. I personally have a folder on my D drive called printer firmware, so I'm just going to type here X1 video, just so I know what this is. So you can extract this to wherever you want. I'm going to go ahead and just copy this path because we're going to need this later. So I'm going to extract all the files in here, and we're going to go ahead and open up Visual Studio Code. Now, this is assuming you already have Visual Studio Code set up on your computer. If you don't already have Visual Studio Code, if you look at the top here for the installation directions, we go over the printer LCD firmware update and then the printer board firmware update, and there's a link right here that says set up VS Code with our installation guide. So you need to have that done now. So if you're watching this on a replay, go ahead and pause the video and set up VS Code and then come back to it. I already have VS Code set up on here. You can see I already have my testing firmware when I was doing the development on this open. So if you have another project or something, go ahead and close it. But I'm now going to go to File, Open Folder. I'm going to paste in that path that I extracted the firmware to. And you'll see you'll have two folders, Firmware and LCD Firmware. We want to go ahead and double click on Firmware and then hit Select Folder. If you click on any of these, you will screw up the process. So you need to click on Firmware and then hit Select Folder, and it should say Firmware down here. If you do not do this, you will not get it opening correctly. And I can't tell you how many people are, leave comments or, send us contact requests, be like, I can't get the check mark down here. Well, it's because you didn't open it correctly. So you need to make sure you are opening it correctly. And if you see here, we're greeted with the platform io.ini file, and this has all the different CPU build types listed here. And since we are not using an STM processor, remember we looked at our CPU earlier, in my case, I have the GD32 F103 RCT6. So I need to change my default environment setting from the STM32 one to the GD32. And to do that, all you do is just double click, right click, copy, and we're going to go ahead and paste that over the existing default ENVS line here. So you can see here, I've now changed it for my particular printer. I'm going to do a Control S and save. And now I can go ahead and actually open up my firmware and edit it. So to do that, I'm going to go to Marlin on the left here, configuration.h, and since I'm using the stock LCD, all I need to do is tell that I have an Aquila X1 by removing the two lines here, and you'll see they light up, and that's it. That's as simple as it is to build the firmware. You tell it what processor you have if it's not the STM32 F103 RCT6, and then uncomment the line here. Now, if you have if you're adding on the Easy ABL, which is our auto bed leveling system, you would also then tell it you have the Aquila X1 OEM mount if that's what you're mounting the sensor for. So we actually design the probe mount so you don't have to, and measure everything so it's as simple as possible. Now, in a video I'm going to post after this, we will go over installing the 128/64 conversion kit, which will get rid of this color LCD completely and give you a very smooth experience. Yes, it doesn't look as pretty, but those LCDs work perfectly in Marlin. So these color LCDs are made by companies called DWin and Dacai, D-A-C-A-I, and they do not publish the full source code for their screens. So any support in Marlin has been kind of hacked together from the community. Whereas the 128/64 LCDs, they are driven directly from the processor, so Marlin's able to fully control them and things just work better. But it does work well enough, and I'll show you guys how it looks after we get the firmware updated. So all I need to do now, since this is a stock machine, I'm not using any auto bed leveling, I don't have any other upgrades, I'm just going to update the firmware. So go ahead and click the little build icon here, which is just a checkbox. And depending on the speed of your computer, it can take anywhere from a minute up to 5 or 6 minutes. It will go ahead and pull down files from the internet to actually build the firmware. My computer already has them because I do firmware development almost every single day on this machine. So just give it time to go through and compile. If you get any errors, read the error messages. Sometimes I've had ones where it will just say it couldn't create a file, and it's just because Windows is being Windows, and you can just go ahead and hit the little build check mark again. Now, where this machine differs with the firmware in terms of other ones, if you guys have used our firmware on like Creality machines or Easy Board, is the SD card actually has to have the firmware file placed in a folder on the SD card. So I have just a FAT32 formatted SD card, and this is what you need to use. So you can see my SD card is formatted as FAT32, and I actually need to put the firmware file it just built into a folder on the SD card called firmware. So we create a folder called firmware, and now we're going to go ahead and copy the file it built to the card. So if I click PIO on the left here, build, and you'll see the folder name here, and this will be different depending on what value you used here for your default environment. So if you use the STM32F1031, your folder will have that name. So basically whatever you used here, that's what this folder name is going to be. And to get to that folder, you can either right click on this and hit reveal in File Explorer and it'll pop it up. That's typically what I do. And if we go into that folder, we'll see we have a bin file. The file you want is the bin file. Now, on some of these builds, if you do back-to-back builds, so you click build again, you will probably end up with multiple bin files in the folder here. You want to make sure you're grabbing the latest bin file based on the compile date. So you can see here, I just rebuilt the firmware and now I have 2 bin files, but you can see the file name changed, the number is actually higher, and we can also see the date modified is newer. So I'm going to make sure I grab the latest file here, which would be this one, and we're going to just drag this over to the firmware folder. So on my SD card, I've got firmware, and then inside that folder, I've got the firmware.bin. Now, before I pop this into the printer, I'm going to go ahead and copy the LCD files. So I extracted all those folders from the zip file to this X1 video folder. And so if I go back to this X1 video folder, we can see we have LCD firmware. So I'm going to go in here, go into the DON Dockeye Color LCD folder, and there's a zip file in here. Inside this zip file is a bunch of folders and a like little text file here with Chinese characters. These need to go onto the root of your SD card. So we can actually use the same SD card to update the display and update the printer. So it's copying those over. So basically I have a fully loaded SD card ready to go to update my printer board and the LCD. So the first thing I'm going to do is eject this from my computer. I'm going to safely remove this. And now we're going to switch over to the printer view. Now, updating the LCD firmware is actually pretty easy. It's kind of a pain, and this is one of the reasons I don't like these, because every time there's a firmware update for the LCD, which is typically whenever there's a major Marlin release, you have to disassemble this and update the firmware on the LCD as well as your board every time there's a major update. Whereas these style screens, which we'll be showing in a later video how to put these on, do not require you to open them up or do anything. It's all updated in one go. But on this printer, if you just kind of pull on this, it'll pop right off. And you can see here my cable unplugged automatically. But there's 4 screws here, so we're going to go ahead and take these 4 screws out. And now we can take this back panel off, just kind of give it a nice little tug there. And you can see we have an LCD, or we have an SD slot here on the back of the LCD. Take your SD card with the files we just put on there and put it into the little slot here. You can see it's kind of a pain. Now go ahead and plug the cable in. And I'm going to turn the printer power on. Now, I already have the firmware updated on the board, so we will get a display. But if you are installing this for the first time, you won't actually get anything on the display after it's done updating. You then will have to update the printer board, and I'll show you how to do that. So let's go ahead and turn this on. And you can see here the screen turns blue. If it's updating correctly and the card is formatted correctly, it'll turn blue, and then after a little bit, it will go to an orange color. If it doesn't do what it just did here, that usually means that your SD card is not formatted correctly. Not only does it have to be a FAT32 format for the LCD to update, but it also has to be a 4096 allocation byte setting, and that's an option you can select when you right-click and hit format on the SD card. So once it goes from blue to orange, the update's done, and we can turn the power off. I'm going to take the SD card out, And make sure you take it out, because every time you turn this on, if this card's in there and it sees those files on there, it does not delete them. It will update every single time. So now I'm done for this update here, and I'm going to go ahead and reassemble my LCD. Plug the cable back in, make sure you get the keyed correct, and then go ahead and snap it back on. Now I'm going to take the SD card. Remember, we put the firmware file on here. We're going to put it into the slot on the printer over here, and it goes with the pin side up. And turn the machine on. Now, if it updates the firmware, you'll see this screen turn white, and then you see this little bar come across. After this, it'll flash like it did, and then now you'll see our screen. So now this has our firmware on it. This is ready to go, and just like that, we have the firmware updated with the TH3D firmware and the LCD. Now, here's the thing I want to point out that I don't like about these LCDs. Is they're kind of flickery. Now, again, I don't know how well this shows up on the YouTube video replays, but it's kind of annoying, but it's functional. This issue does not happen with the 12864s, but again, we're kind of hacking around the limitations on these screens. But you can see here, we've got a full menu system here, just like we would on the 12864s. I can go ahead and do an auto home here. And actually, before that, I'm going to follow my own directions, and I'm going to reset the EEPROM. So to reset the EEPROM, you go into the menu. So we're at the home screen, press the menu button, go to Configuration, Reset EEPROM. And it'll make a little beep. So let's go ahead and auto home. Everything is all hooked up. And this little guy should be ready to go and print. There's our X and Y, and now it's touching off the Z. And that's it. So now we have the firmware for the LCD updated, and we have the firmware for the actual printer itself updated. So at this point, if I wanted to go ahead and get my Easy ABL working, I can go ahead and replace the Z end stop with the Easy ABL control board here, give it power, and then update the firmware. So now I have full control over my printer. I hope you guys liked this little quick stream. I mainly made this just so we would have a replay video, so people that were wondering how to do the full update have it. The biggest thing with this printer, like I said, is making sure you check the processor that is on your control board. The GD32, the N32, and the STM32s are all supported. If yours says H32 or something like that on the board, those processors are not supported. As far as I know, there are no working Marlin builds that 100% work on there. And if you have one of those, the recommendation would be to replace the board. Now, I am going to see if our Easy board can actually be bolted up into this, because the layout is very similar to a Creality board. If that's the case, there's a lot more board options if you do have one of those H32 CPUs that aren't supported right now. They might be supported in the future, but as of making this video on April 5th, 2022, they're not supported. I looked around to see if anybody got it working, and everything is kind of a work in progress where not even basic functions are working. And you know, that's just wanted to put that out there. But it seems like the majority of the printers that shipped out either came with the STM32 CPUs or the GD32s. So if you have one of those or the N32, then you can go ahead and update your firmware, and this is free on our website. So the sales from our shop, whether that's, you know, purchasing upgrades like flex plates or auto bed leveling system stuff, allow us to do this work and give you guys firmware that gives your printer new life and, you know, actual control over your machine instead of having to deal with the manufacturer's stock firmware. If you do want to get rid of the touch, or I call it touch, the color LCD, and have one that doesn't have weird artifacting and it just works smoothly with Marlin, just keep an eye on the channel. We will be posting a video on showing how to swap the LCD out to one of the Creality 12864 styles, and that's already supported in the firmware, and that's a very easy upgrade. You literally unbolt the stock LCD, bolt the new one on, and update the firmware. So anyways, I hope you guys enjoyed this video, and I will see you on the next one. And as always, happy printing.